Hey there, Chem 2. This is my first adventure in doing this. So hopefully it will work out for you and it will help you in the long run because I don't want to talk all the time. I want you to enjoy some free time for yourself. So this is a review session for the data analysis. Um, so this is just like all the math that you need to remember. So we're going to spend some time doing that. So that's why I want to do this. So then we could spend some free time together. Okay. Scientific notation. Yes, yes, yes. That is always important. So many people forget how to do it. It's very important to use a calculator. Every calculator has an EE or EXP button, and you got to make sure you're able to use it properly. So always check your calculator on how to do it. Some calculators you got to press EEE, then your exponent, and then some calculators you got to hit the number, then the exponent value. So it really depends upon your calculator. So that's why it's always good to have one calculator that you can always use for the class. Hint, hint. All right. Again, you're going to find out when I do one of these, I always kind of jump ahead and talk more before the font or that bullet comes in. So as you can see, it just condenses a very large number, a very small number, because as you know, every calculator can hold so many numbers. And so if it holds 6 figures and you have a figure that has like 20 units, exponents are going to be very, very helpful. And like as I told my former chem classes, is that you got to think about it. You know, if I said 17 billion, it's kind of hard to think 17 000 000 000 000. But, if you say 1.7 times 10 to the 10th, you have a better idea of where that value comes. I think it's more important when you work with very, very small numbers. Because again, in chemistry, you're either going to be working with very, very small numbers or very large numbers. And believe it or not, hashtag, there's a proper etiquette for exponents. The rule of thumb is, and again, this is actual IUPAC regulation courtesy, is that you should put things in scientific notation if your value is larger than 1,000 and less than 1,000. So you think about it, if you go, hey, mom, hey, dad, can I have, $20? Of course, we know what it is, $20. You don't say, hey, mom, hey, dad, can I have 2.0 times 10 to the first dollars? So that's something to think about, in reference. Courtesy. See, you learned something new today. Okay, again, 2 parts. Okay, so again, you got the coefficient and you got your exponent. And that's very, very important. Your exponent, your power of 10. And that kind of throws some people off. Because sometimes some people like to use that caret button. And I always tell them, no. When you're doing scientific notation, you're moving the decimal point. So that's what you're doing. So that's what the exponent's for. That caret thing is usually a multiple, like 2 to the 3rd power or whatever. So that's something you got to remember. That caret is much different than the exponent button. And again, there's some examples. If you take 6.02 times 10 to the 23rd, all you got to do is 6 and then move the decimal point 23 places over. And again, you have a calculator that can change an exponent into a value. But that number right there, that 6.02 times 10 to the 23rd, I think that's a very large number that your calculator won't be able to handle all those numbers. So hence the exponent is important. Okay. And then if you look right here, you have 2.0 times 10 to the minus 7th meters, and you just move the decimal point over to the right 6 places, because again, you got to move the decimal point. It's not 7 zeros in front of the 2. Also, another proper etiquette. Look at this. You learned all this proper etiquette stuff. Woo! Is that anytime you have a value less than 1 or anything that's like decimal form, you should put the 0 in front of the decimal point. Again, proper etiquette, the IUPAC kind of rules. I know, so many rules. But again, you have to realize is that we're in a universal situation where these numbers or these units that you're writing for got to be able to be understood by anyone around the world. So if you don't do it properly, you may get some mistakes or many questions about, hey, what value are you trying to prove? Okay. All right. I'm sorry. This is exciting. This is so new and so different. So, okay. All right. So I guess again, these are the notes from Mrs. E. And so she says, use Appendix CR63 for instructions on how properly calculate numerical and scientific notations with a calculator. So I think everybody has a different calculator, and that's going to be very, very important for you to know how to use. All right. Okay. Now, here's the fun part is that when you add or subtract, you know what to do or what to do. Okay. Again, everybody's different. Again, what's kind of nice nowadays with technology is that your calculator will do that for you all automatically. It will do all the, not certifications, but all the exponents for you too. But you got to realize is that you got to put what's inside the parentheses and then close the parentheses. That's something a lot of people are going to make a mistake is that look at the parentheses. That's going to tell you a lot. So if you look 6.82 times 10 to the fifth, that's parentheses plus 5.0 times 10 to the third parentheses. Okay. And then if you look, you want to put, you either can put it into the highest exponent, or many times you let the calculator do the job itself, and you would get that. But if you didn't have a calculator, you would always put use the highest exponent there is. So you take that 10 to the third and make it 10 to the fifth. So that means I just got to move the decimal point a couple more places. Okay? Because if you look right here, you're making that 2 plus 3 equals 5. All right. I feel like I'm a math teacher. Okay? Again, look at this. I already stated this. In order to add or subtract that are exponents in scientific notation, the exponents must be the same. So again, it's usually much easier to pick it to the highest exponent. Some people, if you put the lowest exponent, you got to realize that's not going to work. You still got to move the decimal point because the rule is you always put the decimal point after the first real number when you do exponents. I'm like, wow, I'm like doing all this. Yes. Sorry. I'm it's just so excited getting back to all this fun stuff. All right. And again, I think you would have to, could read that yourself, but I'm just giving you the highlights. I feel like a sportscaster, yes. Oh, in this section. All right. Once the exponents are equal, then you can be able to solve for the problem. But again, most of the time your calculator will be able to do that for you. All right. Now multiplication. Again, you have to realize is that you got to realize when you multiply multiple exponents, you're really adding them. So it doesn't really matter if you don't. But again, you have to realize is that if you add your exponents, that means you're going to multiply or divide your coefficients, and you have to make sure you put everything in proper units, which means you have to make sure that decimal point is after the first real number. So you may have to add an extra few exponents or subtract. But again, we're making the assumptions that you have your calculator, and from there, the calculator is going to do the trick for you. So that's the key thing. Excuse me. I just had some dinner. All right. Again, I apologize. I'm telling you ahead of time. Okay. And this is the first time I'm looking at these notes too. So yay. I love science. So again, if you look right there, it's telling you what to do. Division, again, you divide, you subtract your exponents, and you divide your coefficients. And again, make sure that you have the decimal point after the first real number. Oh, accuracy and precision. As you all know, this is something that's very, very important in chemistry. And you always have to make sure that your value is accurate and precise. And Accuracy, it says right here, is the closeness of the measurement to the target value. Precision is the closeness of the measurement to each other. And you got error differences between the measured and the accepted value. And I think many times, if you remember when you did some labs, you had a situation where you had to find your error. You did error analysis. So, like again, if you're supposed to get 100% and you got 97%, it's because you're supposed to obtain 5 grams and you obtain 3 grams. Final minus accepted divided by accepted. So you have all that fun stuff multiplied by 100. So that is something that you have to remember. This is where many times people get a little frustrated, because in the real world, and this is something you have to realize, is that many of the findings in sciences, like in chemistry, et cetera, many times they were found because they weren't accurate. They had good precision, and that good precision ended up getting something completely different. Just like if I don't know if you remember back way back in the 40s, I don't know if you were around by then, by the nylons. So that is something you have to realize. So look at this. You're getting a little history, all this stuff going on. Wow. Again, hopefully you remember to figure out the equation for percentage error. It's always experimental minus accepted divided by accepted. And again, it's always absolute. So absolute just means you never get a negative number. So if it's minus above there, it's just absolute. Okay. And that sometimes some setups have it as accepted minus experimental. You still get the same thing minus accepted, because you're dividing by the accepted, but it's experimental minus accepted divided by accepted times 100. And right there you get an example down there by below. So again, a lot of this is just repeat. All right, and there's an example right there for you. So I think you can do that yourself. Okay, again, percentage error is always positive. Measurement precision. Probably next week, we're going to be doing a lab online, and they're going to ask you to look at some various units and making sure you can read them. And again, this is always the fun part, where to read the liquid. And I think you remember the rules for the liquid. It's always the bottom part. It's almost like a contact lens. The bottom part, that's where you go and look. And I want to use this, but I'm afraid. Let's see if this works. So if you look right here, it's always going to be right where the bottom part of the liquid. So where it's like a contact lens. That's how I always remember it. But again, that's the part to read. Oh, this is not moving. Am I done? Okay. Talk to yourselves while I'm trying to figure out why this doesn't want to do it. All right. So